Hello friends, today we will see two hinge parabolic arch problem number 1. So let's see the problem. So this is our problem. A two hinged parabolic arch of span 20 meter and central rise 5 meter carries a point load of 20 kN at the ground. Assume that moment of inertia of arch varies the secant of inclination of arch, that is I is equal to I0 sec theta. Find the reaction at the support and bending moment for the arch indicating silent points. So this is our problem. Now first we draw a diagram, as diagram of the problem is not given. So here I draw a two hinge parabolic arch. Here is point A, here is point B, and here is point C. C is a crown point. Okay, as per given in problem, span of this parabolic arch is 20 meter, so we consider L is equal to 20 meter. Central rise is of 5 meter, that is this is H. Small h is equal to 5 meter. Central rise is given and carries a point load of 20 kN at the ground. At the ground, one point load is given of intensity 20 kN given. And now this is our problem. We have to find out the reaction at the support and bending moment of the arch. Okay, let's see how we find out the first we find out the reaction. So first step is to find reaction of the 2 hinge parabolic arch. First we see the reaction generated at the 2 hinge parabolic arch. So here is a one hinge point and here is another hinge point. At the hinge point there is always two reactions generated, that is one is in vertical direction, another one is in horizontal direction. Similarly at B point also there is one vertical reaction and there is one horizontal reaction. Now we have to find out this VA, VB and HA and HB. So let's start solving step by step. First step is to find the vertical reactions, that is we find the vertical reaction VA and VB. So VA and VB will be found by using the equilibrium conditions of equilibrium easily, or this 20 kN acts at the center, so we can directly write as VA is equal to VB is equal to 10 kN. This 20 kN forces will be distributed uniformly over VA and VB, so we can directly write down VA is equal to VB is equal to 10 kN, or we can VA and VB find by using the equilibrium equation. That is first equilibrium equation, summation of moment at point A is equal to 0. If we take moment above this point A, moment above point A is 20 into 10 minus VB into 20 is equal to 0. So this VB become 10 kN, and by using second equilibrium equation, that is summation of f of y is equal to 0. So summation of f of y is nothing but addition of all vertical forces. Vertical forces is present VA and VB minus this 20 is equal to 0. As VB is already we find, so VA is equal to this minus 10 plus 20 is equal to 0. So this becomes VA is equal to 10 kN. Like this we find out the VA and VB. Okay, now we move for the second step. So here VA and VB we already find out. Now we have to find out these horizontal forces HA and HB. That is, this horizontal forces is called as a horizontal thrust also. So second step is find horizontal thrust, that is horizontal forces H. Okay, since this is two hinge parabolic arch, we cannot use moment at crown is equal to 0 like three hinge arches. If you remember, in three hinge arches, if we want to find horizontal thrust, we take the moment at point C is equal to 0. But this is not a three hinge arch, this is a two hinge arch, so we cannot use this equation. To find the horizontal thrust, we take formula H is equal to integration of my dx divided by integration of y square dx. This formula we already seen in last video. So first we find out the integration of m into y dx is equal to 0. M into y, integration of m into y into dx. M is nothing but the movement and y is nothing but the distance. Here we see this is our parabolic arch. In this parabolic arch there is a two segment, that is, one is AC segment and second segment is CB segment. First we take the section at AC segment like this. This is the XX section. It is present at x distance from this point A, and we will take the moment at this x section. So here we see, if we consider the left hand side of the section, this VA is rotating in clockwise direction and this HA is rotating in anti-clockwise direction. So this VA produces a positive moment and this HA produces a negative moment. So we will take the moment about this section. Before that, we consider this is a height y where we take the section. So m into y is equal to integration of 0 to 10. Va is equal to 10. So 10 into x into y. Y is nothing but the this y is calculated by using the equation of parabola, that is 4h divided by L square Lx minus x square dx. So we will solve this equation. Before the solving, we consider the only half portion of the parabolic arch. We have to select the second part of the parabolic arch here. Now we take the section XX in this second segment CB also. Here we consider the x distance from the B. Now we have to take the same moment, that is plus integration of 0 to 10 into x 4h L square L into x square dx. Okay, so we will solve this equation. So here we see this part and this part is similar, so we can write this as 2 into 0 to 10 into x 4h divided by L square Lx minus x square dx. So here we take all common parts outside the integration, that is 2 into 10 into 4h divided by L square integration of 0 to 10 x into Lx minus x square dx. Now, so put the values 2 into 10 h 4 into h is a 5 meter divided by L square is a 20 integration of 0 to 10 x into Lx minus x square dx. If you put directly into the calci, you will get the directly answer. This whole answers comes as 4166.67. This is the integration of m into y dx. Now we find the second thing, that is integration of y square dx is equal to. So integration of y square dx is total span of the parabola is 20 meter, and h is equal y is equal to 4h divided by L square Lx minus x square of whole square dx. So we will solve this equation. 0 to 20, 4 into h 5 meter, L is 20 meter is given, into 20 into x minus x square into whole bracket square dx. Take all constant term outside the integration, that is 4 into 5 divided by 20 square whole bracket square, 0 to 20, 20x minus x square bracket square dx. If you put all these values in the calci, you will get the answer. This becomes 266.67 with the integration of y square dx. Now using these two values, we will find the value of h, that is the h is equal to integration of m into y dx divided by integration of y square dx is equal to, so m into y dx is equal to 4166.67. We put the value 1466.67 divided by y square dx is 266.67, so it becomes 15.63 kilonewton. So this is the value of horizontal thrust h. This horizontal thrust is same for both the end, that is the HA is equal to HP is equal to h, and it is equal to 15.63 kilonewton. So like this we find the reaction at the supports. Here in first step we find VA and VB, and in second step we find HA and HB. So here now we have to find out the bending moment also. So to find the bending moment, we do the step number 3, bending moment calculation. So see, this is our 2-hinge parabolic arch. We have to find out the bending moment diagram. To draw a bending moment diagram, we have to calculate the bending moment at point A, bending moment at point C, and bending moment at point B. Let's see. Let's find out the bending moment at various points. First, we find the bending moment at point A. We can directly write this is equal to 0. Second, bending moment at point B is equal to 0, because this A and B point is a hinge point, and as we know, at the hinge point bending moment is always equal to 0, so we can directly write as 0 due to hinge support. Now we have to find out the bending moment at point C. Here. So here is our diagram. We have to find out the bending moment at point C. Consider any section right or left hand side and take the bending moment. Here I consider the left part of the section and take the bending moment. In the left part, VA and HA is present. VA rotating in clockwise direction and HA is rotating in anti-clockwise direction. So VA is equal to 10 and it is at 10 meters from the C. So it becomes 10 into 10 in positive direction minus HA into height 5 meters. This HA value is 15.63 as we calculated here into 5. So bending moment at this point become 21.88 kilonewton. So this is the bending moment at C. Yeah. So here we find all the bending moments at all the point. Now we will draw the bending moment diagram for the two hinge arches. To draw a bending moment diagram, first we draw a given parabolic two hinge arch. Here is point A, here is point B, here is point C. So at this point bending moment is equal to 0. At this point bending moment is equal to 0, and at this point bending moment is equal to 21.88 kilonewton. Let's join this point. Okay. Now this is your final bending moment diagram of arches. This is negative bending moment, as this is below the arch. This is also a negative bending moment. This is the below the arch. This is the positive bending moment. This is in upward side of the arch. So this is your final bending moment diagram of the arch. Thank you.